So we're going to keep going in this Chapter 5 in Algebra. And the next term we're going to be looking at with inequalities is something called absolute value. And if you remember absolute value, we've done a couple things so far this year. It seems like each chapter we're coming back to it, and that's going to be true as we go through. So here we have this, when we're looking at absolute value, we have these variable inside of something. Okay, an absolute value kind of gives you, or should make you think or realize that it can be a positive or negative number. Okay, so like if we had this, let me show you. So if we had the absolute value of x equals 3, let's say that was it. So an absolute value just really tells you how far something is moving on a number line. So we could really put in here -3, so the absolute value of -3 from 0 is 3 places, and the absolute value of +3 from 0 is 3 places. So either one of those answers would fit. So we have two possibilities. It doesn't take into consideration negative or positive. It's just talking about the distance it's moved on a number line. So if we keep that idea in mind, here we have the absolute value of x is less than 3. Okay? And then we graph that, and you're going to see we kind of get two pieces of this graph. So right here we have this. What would fit for this is we could go from 0, we go right up to 3, but we don't color in the 3, so it doesn't quite fit 3. So any of these in here would fit into this and make this true. It would be less. It's like we did like 2, -2. Plug that in here, the absolute value of -2 is 2. 2 is less than 3. We could go the other way. We go this 2 over here. We could plug it in. 2 is less than 3, right? Just moving 2 spaces. Okay, so if we look at, so when we're looking at an absolute value, when we look at this, we should see that we have two possibilities. Okay, so we're going to get like almost like a compound inequality. So you see here, for this one right here, this x, the absolute value of x is less than 3, we really come to the conclusion that x is less than 3 and x is also greater than -3. It kind of fits in this range, which is like an intersection, because if we graphed it, or if we graphed the absolute value of x is less than 3 on this side, with just a +3, we just have this graph right here. And then if we did the -3, we'd have this side. So for an absolute value, we just make an intersection and we form the entire graph for it. Okay? And then if we're going to use the proper notation, we'd say x, and then we'd have -3 is less than x, and x is less than 3. And that's kind of our solution set. And then let's look at how we get to that though. So if we're just starting out with this, x is less than 3, we can see starting at 0 which directions we can go. But how does that look a little differently with numbers? So let's kind of look at that now. So here we have the absolute value of m plus 2 is less than 11. Okay, so we have to remember, just like we had at the top, we have the positive and the negative possibilities. So we're going to do the same thing here. So we have two cases. We have this one, we just remove the absolute value bars, and we just say m plus 2 is less than 11. The other one, though, we make it a negative, and what we're going to do is we're going to attach a negative to this. Remove the bars, but then we're going to run a negative through this. Okay? And we run the negative through both sides so we don't change it. So then this becomes, in the end, we end up with m plus 2 is greater than -11. Okay? And then we would just solve these. So the m plus 2 is less than 11, gives us m is less than 9. And then on the other side, we would have m plus 2 is greater than -11, will give us m is greater than -13. And I want you to see here, don't forget, anytime you're multiplying a negative through something, it's going to change the direction of the side. So we started off with m plus 2 is less than -11, and we would kind of start off with just negative on this side, but then as we run it through and we do the -11, we're going to change this over and it becomes greater than instead of less than. So then we end up with the range. M is less than 9 and m is greater than -13. Okay? So let's see what that looks like on a graph. So here you see the graph done. I haven't done it for you, I just had it done and showed it to you. So here we have, this is the m is less than 9, so we start with line. It's less than, it's not equal to as well. So we start here, everything to the left forever, right? And then we have m is greater than negative 13. We would start here, and we go all the way to the right around the world forever. Okay? And then what we're looking for is where is the intersection where both of these are found. Okay? And we would see it starts at negative 13, which is right around here, right? And then we would go to, looks like right here, we have 9. So that would take us up to about here. Okay? So then we could take this intersection, put it down here. We would have, here's the negative 13, doesn't include it, goes all the way up to 9, doesn't include it, and that's our union that we have between these two different graphs for these inequalities. So that's one example of that. So if we look at one more example, we have the absolute value of x is greater than 3. So then here we know, this is kind of the one we started off with, right? So the distance between x and 0 is greater than 3. So it can be, so x can be less than negative 3, and then x can be greater than 3 as well. Okay, so because remember, we're doing the absolute value of x is greater than 3. So any number either side, negative that's greater, that's going down, or 3 that's going up. Okay, so then we look at this each way. So we would then write each inequality. So x is less than negative 3 because it starts there. So we make this, we can do this on one number line. So x is less than negative 3, and then x is greater than 3. We do this one on this side, and then this is called a union. And that would be our inequality, our graph for that. Okay, so then that's another example there. And then another example, let's look at. If we have, so this one says solve. This has 3n plus 6. The absolute value is greater or equal to 12. So then what we're going to do again, we're going to solve for the positive, and we're going to solve for the negative. So here we have the positive. We're just going to take the bars away, and we're just going to solve it, because we have 3n plus 6 is greater than or equal to 12, minus 6 on both sides to get rid of that 6. We get 3n is greater than 6, divide by 3, we're going to get n is greater than or equal to 2. The other side, we have to do the negative part of it. So here, again, we remove the bars, and then we have 3n plus 6. Okay? And then we're going to run a negative through this side. When we then do that, okay, we're going to multiply both sides by negative 11, removing this negative sign. This then becomes 3n plus 6. This then becomes 12, because we're going to multiply that negative 1 on this side as well. And then remember, you're multiplying by a negative, so we have to change the direction. This one is greater than or equal to. This will now be less than or equal to. And we get negative 12. Then we solve this one. Again, we're going to add minus 6, not add. We're going to minus 6. It's going to give us 3n is less than or equal to negative 18. Divide by 3. We're going to get n is less than or equal to negative 6. Okay. Then we can then take these two things and put them onto a number line and see what they look like. So this kind of gives our answer here. We came up with these two answers. N is greater than or equal to 2. That's this right here. And then we could make this out, whatever. Make it longer, show some more numbers. But again, we know everything greater than or equal to, we fill that in. 2 is true all the way around the world. Just keep going forever. And then however long that number line would be. But then we also know n is less than or equal to negative 6. So we start here. It's equal to as well. We color it in. And we go to the left forever. So then that is our union graph for that. And we should be good for lesson 5.5. Those are absolute value inequalities. We will make sure you add these notes to your notebook, and we will do a couple examples in class together, and then you can work on your homework tomorrow. See you in class tomorrow.